And now we're on the final part of section 5.5. The last new derivative rule that shows up here is how do we derive a log that is not a natural log? So derivatives of logs with different bases. And again, I'm going to compare it to what you already know because it makes it so much easier to remember something if we can relate it to something that's already in your memory bank. So let's talk about the derivative of natural log of x. So the derivative of natural log of x was just 1 over x, just the derivative of x over the original. You'll notice if it's the log of a different base, it's still 1 over x, but the extra piece here you have is you have a natural log of a as part of the denominator. So you end up with 1 over x, ln a will be part of it. And you can rearrange those, but I think the natural log just makes more sense at the end, so you don't try to combine the x with the base number. If you're deriving a natural log of some function of x, we called it the natural log of u. The derivative was du over u, the derivative of what you're taking the log of divided by it. Same thing here. It's still du over u, but you also have a natural log of a that is part of the denominator. And that's a constant piece, and it can kind of move around if you needed to. So I'm going to take you through 4 examples again. So our first one is just log base 6 of x. So you're going to have 1 over x and then a natural log of 6. Again, the reason we didn't need to do that with natural logs is if you put a natural log of e, that again equals 1. So it was not necessary with base e. We can mix trig in here if for no other reason than just to review our trig. So the derivative of cosine is negative sine over cosine, and then the natural log of the base number. If you want to simplify that to a tangent, you can write it as negative tangent of x over the natural log of 4. You don't see a ton with product rules and quotient rules with the logs, but you will see properties show up a lot, and that's a good review of what we did earlier in the chapter. So before we start deriving this, I want to use any property I can to simplify it. So currently it's under a square root, so that's the 1/2 power. So it is legal by my power property to bring that 1/2 out front. And then my derivative, I'm still going to keep the 1/2, and if you want, you can just put everything else in parentheses. You're going to take the derivative of 4x squared plus 1, which is 8x, over 4x squared plus 1 times the natural log of my base number, which in this case is base 3. You can simplify if you want. You can take half of 8x, or you can just leave it. And then my next one, I'm going to pull it apart with properties first before I start deriving it. So I'm going to bring the 4 out front. So it's 4 log base 2 of x minus log base 2 of 5x squared plus 2. As you use those properties, whatever your base starts at for your log, it will stay. So my derivative, the first one, the 4 is just going to be part of the derivative, just a coefficient. And then I'm going to have over x natural log of 2 as the rest of that term's derivative. And then minus the derivative of 5x squared plus 2 is 10x over 5x squared plus 2 times the natural log of the base, which is 2. Not really anything I can do to simplify that, so you end up with kind of longer answers, but hopefully each individual one's not too difficult. That's the end of the derivative part of 5.5. We've got a little bit with integration to do on the next day, but this takes you through all the basics and all the derivatives.